Lesson 7.1 covers some rules that we use with exponents. Specifically, we're working on zero and negative exponents within Lesson 7.1. Please no calculator today, since you won't be needing them working with these rules. If you look at this table, we're going to fill in all the values that we know. 2 to the first power is just a 2. That may not be quite visible enough. So we'll see if we can use the purple. Maybe that'll be better. Maybe not. 2 squared is 4 because it's 2 times 2. 2 to the third is 2 times 2 times 2, which gives us 8. So that means 2 to the fourth is going to be 16. If you look at that, there's a pattern there. 16, 8, 4, 2. So as we go down, it's like we're dividing it by 2 every single time. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. So if we continue that pattern, 2 divided by 2 is 1. If we again continue that pattern, dividing by 2, 1 divided by 2 is just like saying 1 over 2, so 1/2. And if we do that again, dividing by 2, we get 1/4. So that's a pattern that we'll be working with. If we do a similar process on the other side, 10 to the first power is just 10. 10 squared is 100. 10 to the third is 1,000. 10 to the fourth is 10,000. Again, you'll notice that each time going down, we're dividing by 10. 10,000 divided by 10 is 1,000. 1,000 divided by 10 is 100. 100 divided by 10 is 10. If we divide this again by 10, which happens to be our base, 10 divided by 10 is 1. 1, if we continue the pattern, we would get 1/10. And continuing it again, we would get 1 over 100. You'll notice in both of these situations that anything to the power of 0, or to the 0 power, if we look at both of them, they both ended up being 1. So we know that anything to the 0 power is 1. That's the first rule you want to write down. Anything to the 0 power is 1. You'll also notice that when we got into this negative exponent range, right here, our simplified value of it became a fraction. The number that was either increasing or decreasing moved to the other side. And all of these top numbers, 16, 8, 4, 2, or 1,110, all of the value is in the numerator, because we can always say 10 over 1. The value is in the numerator. You'll notice when we get to the negative exponents that that moved across the fraction bar line. So we want to keep no negative exponents, and to do that, we move it across the fraction bar line. So that's the second one you'll want to write down, and the second rule that we'll be working with today. So again, 0 as an exponent. Anything to the 0 power is 1. 4 to the 0 power, still 1. Negative 3 to the 0 power, still 1. Notice how the negative is inside the parenthesis. A decimal number to the 0 power is still 1. Okay, so that one, easy to forget, but I think you'll get that one down. If we look at the next rule, the negative exponent, I want to be very, very clear with this. The only part that moves across the fraction bar line is the part that has a negative exponent. Okay. That's super, super important because we don't want to get misconceptions with this. The only part that's moving, you'll notice here that we have a, which is representing a number, to a negative exponent. We can always say that there's a coefficient to that a as a 1. There's a 1 in front of it. So the only part that's moving to the bottom is the a to the nth power. The 1 is still staying on top. So that's why it becomes 1 over a to the nth power. It was because a had a coefficient of 1. Just like here, 7 could also be multiplied by 1. We can call it a coefficient. And the only part that moves is the 7 to the negative third. The 1 stayed on top, giving us 1 over 7 to the third, which we could then simplify. Same thing here. The negative, notice how it's in the parentheses, so the whole negative 5 is to the negative exponent. But we could be multiplying that front part by 1, and that is why there is a 1 in the numerator. Only the negative 5 to the second power moved to the bottom. You'll also notice that every single time it moves across, so when that exponent moves across the fraction bar line, it's no longer negative. And that's another important piece to remember. Once we moved it, the negative 2, the exponent, became a positive 2 in the denominator. So if you look at these patterns, 0 to the third power is like saying 0 times 0 times 0. That is 0. Same thing with 0 squared. 0 times 0 is 0. 0 to the first power, also 0. But then we get to this one right here. We have a 0 as our base, which the pattern here shows us that it would be 0. But we also have 0 as the exponent. And we know our new rule is that when we have 0 in the exponent, it has a value of 1. Looking at that, there is no way that a number can have a value of 1 and have a value of 0 at the same time. So that cannot happen. We can't use 0 as a base with a negative exponent. Excuse me, sorry. We can't have two different things, so our answer would be undefined. The same thing here, you can't use 0 as a base with a negative exponent, so like a negative 2. Because if we're using 0 as the base, it's being multiplied by 1, so the 1 stays on top, the 0 squared would go on the bottom. So when we simplify that denominator, 0 squared, we said before, is 0, and we can't have 0 in the denominator. We cannot divide by 0. So this is also undefined. Move on to the next ones. The whole idea today is that we're simplifying expressions that contain exponents, specifically when they're negative exponents and 0 exponents. So we're going to practice a couple. I'm going to rewrite this problem. It's very helpful to always have a 1 times whatever it is that has that exponent. The only part in this problem that's going to move is this negative exponent. It's going to move across our fraction bar to the bottom. The 1 stays in the numerator. And now that we moved this exponent to the other side, it is no longer negative. It's a positive 2. And then from there we can simplify it. 9 squared is equal to 81. So this would be our final answer. When we look at B, this time it's not a negative exponent, it's a 0 exponent. Anything to the power of 0 is equivalent to 1. Notice how the negative is inside, so this exponent goes to that negative as well. So that means this entire thing has a value of 1. Okay, let's do a few more. If we look at this first one, 4 to the negative third power. It has a negative exponent, so we want to show that we're multiplying it by 1. And only the negative part moves across the fraction bar. Only that moves down, which gives us 1 over 4 to the third, which we need to simplify. 4 times 4 times 4. 4 times 4 gives us 16. So then we have 16 times 4, which gives us 64. So our final answer is 1 over 64. Showing this work off to the side is great, especially since within this lesson you're not using a calculator. If we look at the next one, it's a 0 exponent. Anything to the 0 power, including this negative because it's inside the parentheses, has a value of 1. So 1 is our answer. If we look at the next one, it is a negative exponent. So we want to start by saying that we have 1 times that term with the exponent. Multiplying it by 1 doesn't change the value. However, it does make it clear that only this negative exponent is going to move with the number it goes with. The exponent is only touching the 3, so that's the only number it goes with. It doesn't go with the 1 because it's not immediately touching the 1. So then from there we have 1 over, because we moved it to the opposite side, it's the opposite sign this exponent is, so it's a positive 2, and then we can simplify that to be 1/9 as our final answer. We can do the same thing for this next one. We'll have 1 times 6 to the negative first power. Multiplying by 1 doesn't change it. We only moved the negative exponent part to the opposite side, which in turn gives us 1 over 6 to the positive first power, which we wouldn't really need to write, so we can just say that we have 1/6 in simplest form. The final example like this, when we work with it, it's a negative exponent. This negative is inside, so it's included in the exponent. We're going to put a 1 in front of it to show that only the negative exponent portion is going to move to the other side of the fraction bar line. So that'll move to the denominator. Then from there we have, 1 over, it's still a negative 4 inside. The only part that becomes positive is the exponent when it moves. It's still a negative 4, so we still need the parentheses to show that the negative is included, like it was in the beginning, and the exponent becomes positive. Only the exponent. That's super important. Only the exponent changes signs. So then from here, we would have to simplify that denominator. Negative 4 times a negative 4 is going to give us a positive 16. So we have 1/16 as our final answer for that. The next process is being able to evaluate exponential expressions or expressions with exponents. And then eventually, when we're given the values, be able to simplify from there. The first step you will always do is to simplify first, meaning our 0 exponents and our negative exponents. We want to take care of them first to make what we're working with a little bit easier before we plug anything else in. Okay, so that's what we're going to start with. We're going to ignore this right now. Looking at 3s to the third times, they're right next to each other, so it's being multiplied by t to the negative second power. The only negative exponent is this negative 2. which means in our fraction right now, everything is in the numerator. And the only part that's going to move to the denominator is that negative exponent part. So just the t to the negative second power moves to the bottom. Everything else stays the same. When it moves to the bottom, the negative 2 becomes a positive. So then we'll have 3s to the third over t squared. The 3 didn't move because its own exponent was a positive 1. Positive stay. Same thing with the s. It was a positive 3, so it stayed. Now that we have that simplified, then we'll plug in the next values. We know that s is equivalent to 2, so when we plug that in, we're going to use parentheses around that value of 2. So we have 3 parentheses 2 to the third power over, again, parentheses around the value we plug in, especially when it's negative, squared. Okay? Order of operations is incredibly important when we're working with evaluating and simplifying, especially with this addition of the exponents. Exponents comes before multiplying and dividing, so we have to simplify those exponents first. So that's going to give us 3 multiplied by 2 to the third power. We know 2 to the third power is 2 times 2 times 2, which gives us 8, over negative 3 to the second power. It's an even exponent, meaning we have negative 3 times negative 3. Even means that's going to cancel and become a positive. And 3 times 3 is 9, so we have it over 9. From here, we just need to simplify. And there are a couple ways we could do that. However, I'm just going to use our grouping symbol. 3 times 8 is 24. The 9 stays in the denominator. And from here, we can simplify that equivalent, or that fraction. Both of them are divisible by 3, which gives us 8/9 as a fraction, and our final answer. So we took care of those negative exponents, then we plugged in the values. So let's try a couple more with that. First, we're going to simplify any negative exponents or any 0 exponents. You'll notice both of them exist in this problem. I'm going to start with the 0 exponent. We're going to check them first, because those are easy to miss. We have a 0 exponent right here. Anything to the 0 power is 1. So I'm going to change this to n to the negative 4th power times 1. That's our first step. Then from there, we want to take care of our negative exponent. Using our fraction bar. Right now everything is in the numerator. The only part that moves is this negative exponent part. So that's going to give us 1 over n to the positive 4th power now. It moved across, so the exponent becomes the opposite sign. And now we can plug in our values. Notice this time we don't have to plug in anything for w because it would have had a value of 1 anyways. So we only have to plug in n. N has a value of negative 2, so it's super important that we put parentheses around it. So we'll have 1 over negative 2 to the 4th power, which when we simplify it, negative 2 times negative 2, maybe it's helpful to write it out so you have a visual. Both of those two will become a positive 4, same thing as there, which gives us 16. So in the end, our answer is 1 over 16, 1/16. Okay. If we look at B, B doesn't have any 0 exponents, so we're okay with that aspect. However, it does have a negative exponent, only in the numerator. This 2, w to the 2nd power, is a positive exponent, which means it stays. It stays put. It's going to stay in the denominator, and the only part that's going to move is this n to the negative first power. If there's something in the denominator, that's why it's super important to put that 1 up there as well. So when we move, I'll show it down here, 1 times n to the negative first power over w squared. When we move just this part, now we just have multiple items in the denominator that are being multiplied together. So that's going to look like 1 over, we can put that in alphabetical order, and now to the positive first power, w to the second power. Now we can plug in the values for each of those, giving us 1 over n was a negative, super important to put that in parentheses, to the first power, times w to the fifth power, which is 5, so 5, we can put that in parentheses as well, squared. And then we simplify from there. Using order of operations, we're going to take care of those exponents first. Anything to the first power stays the same, so it's still a negative 2. We can still keep those parentheses around it for now. Multiplied by 5 squared is 25. And then one more step to simplify in the end. Negative 2 times 25 gives us negative 50 for our final answer. For C, you'll notice that it has a 0 exponent. So we're going to start with that. Anything to the power of 0 is 1. So n to the 0 power is just going to be 1. Now we have 1 in the numerator with w to the 6th power in the denominator. No negative exponents, so nothing has to move to the other side of the fraction bar. So now we can plug in, but we only have w to plug in instead. So that'll be 1 over, w is 5, so 5 to the 6th power. And then we would simplify from there. For time's sake, that gives us 1 over 15,625. Again, no calculators for this. Okay, and the last example of this type, checking the same exact process. No 0 exponents, but we do have a negative exponent. You'll notice that the n, even though it's being multiplied by w, has its own exponent of 1. Because it's just a positive one, you don't have to show it. The negative one you do have to show. The negative is telling you, I'm just in the wrong spot. I'm on the wrong side of the fraction bar, so we have to move it. The only part that moves then is the w. N stays because it has a positive exponent. So when we move the w portion, we have 1 w to the positive first power over n. Then from there we can plug in our values. In the numerator it'll be 1 times w, which is 5 to the first power. Anything to the first power is still just 5. And then in the denominator we'll have a negative 2. Because it's the only thing in the denominator, this is the only time you don't have to put parentheses. Then when we simplify it, 1 times 5 is just 5 over that negative 2, which then in the end could be written as negative 2.5. I would say either one of those is okay. Simplest form. Okay. The last example we're going to go over is a word problem. In this word problem, it's going to use an exponential expression, just meaning an expression with exponents. And it's talking about population growth. A population of marine bacteria doubles every hour under controlled laboratory conditions. The number of bacteria is modeled by the expression right here. So I'm thinking this expression is going to be super important because we're working with exponential expressions right now. So I'm going to write that off to the side. Where h is the number of hours after a scientist measures the population size. Okay, so I'm also going to identify that h is the number of hours after measurement. Okay. Our job is to evaluate the expression for h is equal to 0 and h is equal to -3. So 0 hours and -3 hours. So we're going to write this expression 2 times because we're evaluating it 2 times. 2 to the h power, and then again 1,000 times 2 to the h power. The first one we're going to plug in is for 0, when h is equal to 0, what that looks like. Instead of having an exponent of h, we're going to put 0 there, so now we have 1,000 times 2 to the 0 power. We know that anything to the power of 0 is equivalent to 1, so this becomes 1,000 just times 1, which gives us just 1,000. This whole expression, then it's talking about the number of bacteria. So we would say 1,000 bacteria. It's important to think about what it's saying when we're at 0. 0 hours, if 0 hours have passed, or if we're 0 hours after that initial measurement, this is how many the scientist initially measured. Or in the very beginning. So that's the first part, when h is equal to 0. If we check the other one, when h was equal to -3, we would plug in the -3 for h. And then showing these steps to simplify will be really important. We'll have 1,000 multiplied by 2 to the -3rd power. This time we have a negative exponent, so only the negative portion moves to the opposite side of the fraction bar. And the 1,000, excuse me, stays. So that gives us 1,000 divided by 2 to the 3rd power. Notice the exponent is now positive. So when we simplify it, we have 1,000 divided by 8, which gives us 125, which means 125 bacteria at the hour, the -3 hour. We want to think about, what does it mean? And the question is asking, what does each value of expression represent? Well, the 0 hour was right when the scientists measured it. The population, according to this, is supposed to double every hour, which means it's supposed to grow. Over time. You'll notice at the -3rd hour, it was a lot smaller. So we can say then that because it's negative on a number line happens before the 0 hour. The 3rd hour would be over here. The -3rd hour would come before, which means it's 3 hours before the scientists measured. Throughout this lesson, we were working on 2 different exponent rules. Those exponent rules were 0 exponents and negative exponents. Anything to the power of 0 is equivalent to 1. It's important to remember these parts when working with negative exponents. Only the negative portion, the only part that moves across the fraction bar is if it has a negative exponent. And when that exponent moves, across the fraction bar line, it's no longer negative. It becomes that opposite exponent sign, and only the exponent is affected in this way.